With that, I'm going to introduce our last speaker of today's session, and that's Mr. Russ Kupferer. And he is going to be speaking to us about threat integration for full spectrum survivability assessments. Thanks, Russ.
How do I make it big?
I forgot to hit. Sorry. I left you hanging. There we go.
All right, cool. All right, good afternoon officially, everyone. I know I'm the last presentation before lunch, so I will try to be brief, but also leave time for questions. Before I get into this, I just want to get three things, sort of preamble. Number one, I'm Russ Kupferer. I am DOT&E Action Officer. I do survivability for ships and submarines. I am not a statistician. I am not a mathematician. I am a worker bee down in the trenches trying to be practical about applying the way forward on analyzing different threats that face our forces right now. So that's number one. Number two, all of my stuff is geared from the perspective of someone who does ships and submarines. They're very complex systems of systems. Every ship is a system of systems. And so that perspective colors some of the commentary I'm about to give. I'm also looking at it from survivability, but if you turn this stuff around, it applies to lethality, and it also applies across the other services, though there are different colors and flavors to how it will be applied for, say, the difference between analyzing survivability of a satellite compared to analyzing a 2-ton truck trying to get across the battlefield. And then the third thing is all the stuff I'm presenting today is general release, but any discussion about survivability involving real systems and real performance goes classified very quickly. And in fact, when we start talking about full spectrum survivability, it's likely to go much more classified than we're used to, much quicker than we're used to. And that's something that I could have a whole different presentation on, the challenges associated with dealing with the classification levels that we're going to have to look at when we're actually putting rubber to the road on these full spectrum survivability assessments. But for right now, we're all talking conceptually, so all the examples up here will be at that from that perspective. So before we get into what we need to do for full spectrum survivability, it's important to consider how we got here. And that basically tracks back to the 2022 NDAA, which directed us to look at full spectrum survivability for our systems. And the language that's actually up there is the language that came with that NDAA to look at including testing against non-kinetic threats. The traditional LFT&E, live fire test and evaluation programs focused on conventional kinetic threats against our systems. You go back to the Pentagon Wars or whatever. Can our systems as deployed take a missile, take a round, and still perform as they are meant to perform, both to save the lives of the people inside the systems, but also continue their missions afterwards? Well, we're expanding it to all the possible threats that these systems might see in combat, and as we will see, it actually takes us beyond combat for certain types of threats. Well, so the next step was, well, we got this this tasking. How do we do it? DOT&E did a study, reached out to different types of programs, Navy, Army, Air Force, to try and scope what the problem would be. That report is available, and the conclusion that came out of that was basically we need a enterprise-level investment to develop both the M&S and the test capabilities to do full spectrum assessments. There are tools out there, there are M&S out there, there are test facilities to do different aspects of full spectrum survivability, but there's certainly no integrated place where we can put all those hands together right now. And in most cases, when you talk about M&S or test facilities, they're very narrowly targeted towards this particular environment or this particular effect. You don't see the kind of integration that you would need to consider all of these things acting together. So DOT&E has provided recommended changes to the LFT&E law. That pen hasn't gone to paper, but we are proceeding as if this is the law of the land, and we're going to be doing full spectrum survivability assessments going forward. So what's the full spectrum of threats out there? So let's start with the ones we understand. Kinetic threats, missiles, bombs, mines, torpedoes, projectiles. Like I said, this is what the threats that came in with the original LFT&E law. All the things that get shot, propelled, or go off in the vicinity of our systems that are out there right now. Now, directed energy weapons have not in the past been treated as kinetic threats, but if you look at the physics, there actually are kinetic threats. Now, there are different ways to use directed energy weapons that don't necessarily result in damage to a target, but still need to be considered in a full spectrum environment. And you see up there, that picture, that's an open source picture of a Chinese frigate shooting a laser at a Filipino ship. These things are out there right now, and they're going to be out there more and more as we go on. Cyber threats. So there are a number of different ways that you could use a cyber weapon to attack a U.S. system. And it's not Hollywood out there. We're not concerned about someone turning around the gun and shooting the bridge, right? We're concerned about those kind of threats that can get in there and tell the bad guys what we're doing, or can interrupt what we're doing, or can interface with the ship or system in such a way that it compromises our ability to trust what we're doing, trust that we're doing it in the way that we think we're doing it, and trust that it's going to be there when we need it. Electromagnetic spectrum operations. So there's, you see this in Ukraine right now. It is a reality of modern warfare that we cannot depend that the spectrum is going to be available for us to communicate, to use our sensors. Those kind of systems are going to proliferate, and they're going to continue to miniaturize to the point where we have to test and we have to consider that any realistic implementation of combat is going to include some amount of spectrum denial and or electronic attack, active attacks against our systems using that spectrum. Chemical, biological, and radiological threats. So we've been, as a DOD, throughout the Cold War, we knew that this was a real threat. We trained to it. We equipped our systems. After the Cold War, some of those capabilities have atrophied. We still have, I'll talk to ships and submarines, we still have the ability to go out into a contaminated area and conduct our missions. But there are systems and testing that needs to be done to verify that those kind of threats, especially if you're considering trying to use, for instance, your defensive systems while dressed out in mop gear, that starts degrading your ability to defend against other types of threats. And finally, nuclear. There is a reality that the world we're living in right now, nuclear proliferation is likely to continue, and it is not inconceivable that we will see some kind of tactical use of nuclear weapons. And that tactical use of nuclear weapons, no one expects our systems to survive a direct hit, but we do expect them to continue operating in the vicinity of a nuclear release. So we need to evaluate those. And it should... This is where full spectrum really becomes important. The cumulative lethality of these effects playing together is what we're about. Because if you're talking about like an anti-ship missile attack, if we have a cyber attack and if you go out on any ship that is in the fleet right now, you get periodic reboots of the system. Some packet drops or whatever, hey, go flip it on, flip it off again. That could be a cyber attack. It could be an undetected cyber attack, and those are the kinds of things that we need to consider when we're talking about full spectrum. If you were an informed bad guy, how would you try to attack our systems so that the combination of all of these different things added up to going from a no possibility of getting through our defensive layers to an almost certainty? And it becomes a pretty steep graph when you consider some of these. So ideally, you just go out and say, well, let's test these all at once. But anybody who's ever actually tried to test something knows that not only is that impractical, but it would be tremendously expensive. That picture up there is a recent test event. Those are 4 SM-2s coming off of USS Michael Monsoor at the same time. That was a great test event, but like that's not something you do every day. And you certainly want to do that during trying to test a cyber attack at the same time and then get no data out of it because, yes, you were successful in crashing the combat system. So when you do a test and when you do a real-world test, the emphasis is going to continue to be testing one variable at a time or a small number of variables at a time so that you get good data that then you can feed back into the other stuff that you do. And so that's where we get into the idea of using full spectrum survivability assessment testing to build these validation data sets. So in the ideal full spectrum world, you're building a modeling and simulation system where you can combine these effects together, and then you go out and do the individual test events to validate different aspects of it. Does the combat system work as it's meant to work? Can the cyber defenses protect the ship? Can the chemical, biological, and radiological systems detect this attack in time for the systems to be activated? You do those tests independently, and then you combine them using M&S. You have a validated M&S at that point individually, and then you do combinative testing as necessary to get those edge cases, those cases where the answer is, I don't know, or it's too close to call. Those are the kind of events where you go back and do some kind of full spectrum test. That ideal of a integrated survivability model, I'm going to be frank, that does not exist right now. There are attempts, ongoing attempts right now to build that kind of model, but it's a very difficult thing to do. I'm not going to get into all the reasons why, but you guys probably can figure out why. So what is the proposal to get to full spectrum survivability if this grand M&S is not out there yet? What I'm proposing, and what I think is not a bad idea, is what I'm going to call survivability vignettes. And the idea would be is that rather than trying to come up with all the possible combinations of cyber attacks, kinetic attacks, etc., what you would do is come up with an informed attack scenario, a specific scenario that you could test the system to that does combinative effects. And it's important to consider when you're putting together these vignettes that they shouldn't just be blindly applied, right? I've seen it in the past where someone will present a kill chain and they'll say, oh, the cyber attack is either successful or is it not successful, and then if it is successful, then you go ahead and go to the kinetic kill chain part of it and you say, oh, combat system's down, so you take all these hits. Well, the reality is if the ship is out there in the fleet and the combat system crashes, they're not going to leave it as the guy doing anti-air warfare. They're going to pull that ship back and try and put another ship in there. So when we're considering these vignettes, not only should they be considering how the different effects are playing together, but it should be a time-phased sort of multi-domain assessment. I don't think you can consider these vignettes, though, without also considering what the adversary is going to do as well. The adversary gets a vote. It would not make sense for them to, for instance, try to jam your RF system, and then when they launch the attack, if the weapons were shot down and they had a second attack coming in, that they would not pull back that attack or try some other approach. So the vignettes can become quite complicated, but that's why we need to sort of go through and lay down those baselines. So, and the last bullet is important. In the past, we've had sort of the luxury, I'm going to say whenever I've presented results from, say, a survivability assessment, we always end up with like a probability of kill given hit at the end of the day. Against this threat, you have a PK of 90%, right? We have to get away from that kind of thinking because that number one, was never as specific as we tried, have as many decimal places as we always tried to put behind it. But also in the concept of full spectrum survivability operations, that number really doesn't have any value on its own. So wrong button. Okay, so let's do a survivability vignette right now. This is a fairly complicated one in that it combines a bunch of different domains, and it's got some cute animations. So let's do it. So we've got a blue combatant. She's sailing around in fairly restricted waters. There's a lot of white traffic around. It's doing its job, looking for bad guys. So what can the bad guys be doing? So potentially one of those boats out there is not white traffic. It's actually someone using ESM to determine where that blue combatant is. The combatant's being smart. It's trying to keep its MCON up, but that guy over at number 1 uses those systems to get a bearing to it. So at that same time, there's a persistent cyber attack that has been going on that's been crashing the combat system. That maybe it's been active for a while, maybe it's been active based off of some other external event, but the crew at that time is trying to deal with that combat system casualty. While that's happening, once they get some indication that the combat system is offline, and if that guy who's listening for their radar says, hey, the radar just went offline, that's a good indication, then maybe this other guy, number 3 down here, moves in with a jammer to try and get close to maybe jam whatever they've got left, jam their communications, something else to add to the ability to keep that combatant unaware that there's going to be this 4th step where a bunch of drones are launched. Now that they know where the target is, they know that it's relatively defenseless, now's the time to press the attack. And those drones move in, specifically targeting the magazines up front on that combatant. Because those drones have shaped charge warheads, and the bad guys know that their best chance of sinking that ship is to put a shaped charge through one of the missiles in that magazine. So that combination of attacks and considerations is how a relatively unsophisticated enemy could get to a pretty significant chance of defeating that combatant despite all of that combatant's capabilities. And if you think about this real quick, this is a hypothetical bad guy doing this to us. This is exactly the kind of stuff that we do to the bad guys, right? So the idea that this is a fantasy, that they can't do it, it's been demonstrated that we can do it, and it's definitely in the capability of some of the bad guys out there. So when we come up with these survivability vignettes, it's not that I can just lay them out for people. In fact, I wouldn't want to do that. We have to work with the different stakeholders in this to come up with survivability vignettes that are accessible and make sense and are credible. So in some cases, it's still going to make sense to do a specific threat in a specific condition, right? So I put up here like a chemical weapon attacking a ship while in a foreign port. I mentioned before talking about situations outside of combat. Some of these, especially asymmetric full spectrum threats, they're going to happen to the ship not when she's out in a blue water environment, not while she's expecting it, but while she's relatively vulnerable. If you look at the Cole, they didn't try and come get her while she was sailing around. They hit her during chow time when she was most vulnerable. So we need to take that into account, but some of those survivability vignettes are a single factor. Other cases, we can go with generic combinative effects, right? ASM EMs coming in while we're denying comms. So you don't have CEC, for instance, to help cue you. That makes sense. That's something that we already do to a certain extent, but then we take it to more complicated vignettes. Say a cyber attack comes in first, disabling the radars, followed by an electronic warfare attack to deny the comms, prevent any other way of sensing off board, and then you do that cruise missile salvo. That's something that you're not going to do on a range, but it is something potentially you can do either through M&S or through some kind of combinative assessment after the fact. You don't want to cover every possible attack, but you do want a wide range of scenarios. So in my mind, the vignettes that you would come up with would be some dozen of these are the different scenarios that we want to evaluate. We want to make sure we're covering ASCMs, ASBMs, torpedoes, mines, etc. We want to make sure that they all get into the threat set so that we get assessments against all of those without trying to game out every possible combination. And it makes sense to work with the intelligence community to come up with what are the most likely ways that the bad guys are going to use these, and then what are the most likely future capabilities of the bad guys for doing that kind of attacks. When we do this, like I said, we move away from simple PDs and PKs, and instead we're going to have to look at the vulnerabilities of the system as far as this is the enabling factor that enabled us to defeat or sustain damage from an attack. And I've been doing that for a long time under LFT&E. A lot of the stuff that we come out, we don't want to focus on the PK because in a lot of cases the PK is low fidelity anyway. But we do want to say, hey, this system is critically vulnerable because there is a single point of failure here, and it's right in the center of the ship, and that is right in the crosshairs of most of the weapons. Please move that to somewhere else on the ship or build in some kind of redundancy that gives you ability to defeat that. Okay. Wait, I'm sorry. Yeah, okay, it didn't switch. Come on. Oh, I'm pushing the wrong button, that's why. Okay. So we also have to talk to how we're going to get to adequacy on these assessments. First of all, we need to figure out how to do this. We're not ready to go all in on this because we need the services to work with us. We can't just lay down the law and say, yay, you will do full spectrum survivability vignettes, and here they are for us. We need to work with the different stakeholders. We need to figure out a process that is workable and that that everyone agrees to in the end. Because I know right up front that if I go to a program office and say, hey, I want to do a scenario where the bad guys take down your combat system and then they shoot missiles at you, they're going to say, you're just setting me up for failure. Why do I need to do this assessment? And the reality is that we need to have them on board as willing partners to see that we're not just trying to beat them up, that we're trying to get honest-to-God survivability answers to improve the systems. So another thing that we have right now is I mentioned that we don't have this M&S capability to wrap all of these things together. There are people working on that right now, but we also don't have the test capabilities and ranges to support many of the individual components of this, let alone some kind of combinative full spectrum assessment. So how do we deal with that? We've got to do different things. First thing is we have a lot of design sites in the Navy, in basically throughout industry, to mock up these systems and test them before we actually field them. We need to use those in new ways. For instance, doing cyber attacks against design sites, injecting combat casualties against design sites that you would not be able to do aboard, say, a ship without possibly doing damage and endangering the platform. Right? We need to start thinking about ways to use those design sites to do these assessments rather than just developing the systems. We need to expand component and surrogate testing. Let's see if this thing works. So that right there is a blast fixture that is built up at Aberdeen, and right now they should be blowing up a door for me to see what the fragility of that door is to overpressure effects. That test literally is happening right now. That's the kind of testing that we need to continue to build on, because if you start scratching the surface on basically across the full spectrum, there are a lot of gaps in our knowledge as far as what the fragility of different components are, what the result of damage to systems will be. There's a lot of assumptions baked into there that if we want to do full spectrum survivability assessments, we need to resolve. That sort of leads directly into the system engineering models and digital twins. There's been a lot of work put into trying to build those models, but also harvest data from those models in a way that we can use them. Realistically, we're not at the point where we can build a digital twin of anything as complex as a ship, largely because a lot of those systems don't have digital representations yet to support that. But that's somewhere we're going, and we're going to continue to build those models based off of that as much as possible and right into the requirements that when we're trying to get these systems put aboard a ship, that they have to provide those kind of digital representations of the systems to DoD so that we can use them for those purposes.
Who pays for that?
So that's a great question. Who pays for any of this, right? So all...
Models specifically.
Yeah, so I think that that's a great question because that's one of the things we've run into a lot of resistance on, right? Let me just do a quick aside. One of the things that is happening right now for vulnerability modeling is they are using the product model for the big L ships, LPD and LHA. They have worked with the shipyards to provide them the digital model, the product model, and they are pulling components out of that model so that they can rapidly populate their vulnerability models. That is great. Those shipyards are basically giving them that because they asked for it. Other shipyards have said, hey, we'll give that to you, but it's going to cost you X many million more dollars. I don't have the solution to that, but it basically comes down to if they're building those models anyway, DoD should have some kind of right to ask for them.
Contractors, the contract writers.
Yes.
Learn how to write that contract.
Exactly. And then finally, expanded system testing. If you can do a test safely and securely, there is no substitute for testing the system itself. That bottom picture, that's Gerald R. Ford with 40,000 pounds of explosive going off next to it. I rode that trial. We busted a lot of stuff on that ship, and we found stuff that could be fixed relatively easily that will save lives if that ship ever faces combat. There's no substitute for going out and actually testing a system, and we need to make sure wherever we go with M&S that we don't get away from saying, hey, we do need a test to go verify that the fixes that we implemented and the performance we expect is what we actually get. So to conclude, we really need to look at this one battle at a time. And I stated right up front that I'm down in the trenches. I'm trying to think about this practically. We don't have the ability to sort of levy a full spectrum requirement on everyone and just expect them to follow it. We've got to do this one step at a time, and that goes to a number of things. Number one, if we are going to use survivability vignettes, we need to do that as soon as possible in the acquisition process, because not only is that going to drive how we test and the test events themselves, but it's going to drive requirements for our M&S and what testing we want to do throughout the entire acquisition process. We need to leverage, wherever possible, our system-based model and do additional circuit testing and expand our aperture to consider full spectrum effects. We can't just focus on doing testing of something in a lot of detail and then ignore the rest. We need to look across in a ship. We're talking literally millions of components. We need to look at them and say, what are the ones that are most important and what are the different failure modes that should drive us to testing? And third test design, we need to be realistic. One of the things that frustrates me is when someone says, hey, we need to test in this environment this many times using this many resources. And the reality is that's not how any of this works, right? I would have loved to test Ford 50 times against various shock effects. We get 3 shots, right? That DDG 1000 event, we got 4 test events, right? and that was relatively a lot. So we need to be realistic with what money we have in the budget and what different leverage points we can get to. And then finally, we need to allow ourselves to move away from probabilistic numbers at the end of the day. It's great for going into a flag level brief to say, oh, this one is 0.3 and this one is 0.73, and say, look, this one's so much better. But realistically, we need to be thinking about what are the inflection points that are causing that difference in survivability, and be realistic with ourselves about the fidelity of those answers. So we're going into a sort of a new era of assessment. When we consider full spectrum threats, it's going to be a bumpy ride. There's going to be a lot of cases where we try a test and it doesn't work, that we need a test capability that will take a decade to develop, where we have to accept some compromises and some limitations in order to get to answers. But if we don't start doing it right now, it's going to fail us when we actually see this stuff in combat. So it's important to move out, be practical, and go as fast as we can. So that's what I've got. Did I make it? I made it.